Hi there, my name is Lockie and I'm a Microsoft Technical Trainer. It's great to have you with me. In this video series, we are going to be looking at virtual networks in all their shapes and forms. We'll cover a number of different bases, but we're going to begin by just exploring the virtual network itself, so you know how everything's put together, what gets put together as part of it, and all of the constituent pieces. But on top of that, we're going to be looking at some adjacent things to the virtual network. Public IPs, how to set up different peering connections between virtual networks, as well as a little bit around traffic routing and controlling how traffic flows in your environment. We are going to cover virtual networks in all their shapes and forms. But mostly, I want to give you an overview of how they function in a more technical level. Different capabilities that they hold, different ways that we can utilize the address space, little things like that. Of course, allocation of IPs is going to be critical, and we'll also be covering how regions are structured in Azure. All of these are going to be important for you to know where you're going to deploy stuff, how you deploy stuff, and how you are going to plan things out. Planning is going to be key in your network development. So let's run through it. Right in front of us, we can see some broad capabilities of Azure Virtual Networks. But before you run through the list on the left, take a look on the right-hand side here. We can see in front of us a structure of a virtual network. At the top end, we have the virtual network itself. It has a CIDR block that represents a pool of IPs that we can select. We've chosen to carve this up into different slices of IPs called subnets, a back-end and a front-end subnet. Each one of these subnets represents a different purpose in the business, and you can use them in a whole bunch of different ways. But there is a lot of different services utilizing this private connection mechanism. Private is the key word. When you create a virtual network, what you are doing is slicing out a chunk of the Microsoft network stack and keeping it private for yourself. Something you can create on demand, and it allows you to facilitate connections through to the internet from internal machines. It allows you to communicate with Azure resources in a private space. It even allows you, through the use of gateways, to communicate with on-premises network resources. There is a lot that we can do with our virtual network. But if you've come into the course at a high level, you probably know a lot of this already. Let's talk to some technical depth. In Azure, the virtual network complies with the RFC 1918 address space. That means you have 3 different private address space ranges to pick from. The 10 dot range, the 172.16 range, and the 192.168 range. Take your pick. You can utilize all 3 in different combinations to meet your requirements. The big thing to remember is that it's a logical structure. So you can create this on the fly and can continue to expand over time. Now, there are a few reserved address ranges in Azure. Most of the ones on the right-hand side in the unavailable address ranges set, they're things that you might be familiar with if you've done networking on premises. Things like multicast, broadcast, loopback, all of these address spaces are fairly common. One you might not have seen before, and will come up quite a bit, is the internal DNS. Now, this internal DNS on 168.63.129.16, this small IP range here is utilized by Azure frequently to allow for internal communication between Azure resources and effectively say that from the get-go, everything just works in Azure. We can always do custom resolution, we can do lots of custom things. But my goal is for you to have a space to privately land your resources from the get-go. And to that token, even the reserved IPs, we require 5 reserved IPs in your environment. Now, this is going to be for each subnet you create, not just at the virtual network level. 3 of those are common networking things. First address, .0, will be the network address, .1 will be the default gateway, and .255 will be the broadcast address. Standard networking stuff. But what's a little bit unusual is .2 and .3. These ones are reserved by Azure to ensure that from the get-go, your resources are able to resolve DNS queries, so they can find storage accounts without an issue and be able to easily look for things with that friendly naming. Again, if we want to customize that, totally up your alley. But from the get-go, everything works, and that is the goal. So that's our virtual network. We've got the stack there, and really the only thing we need to pick beyond what we've talked about there is the space that we're going to make use of. How many IPs do you need for your virtual network on the whole? Once you've got that pie there, we can start slicing it up into different subnets. Here in this example, I've got 4 subnets in total. Subnets 0 through 2 are focused on just different business components. Subnet 0 could be for front-end servers, whereas Subnet 1 is for middleware, and Subnet 2 is where the back-end servers, the databases, live. No matter how you choose to divide your subnets up, ultimately, you just need to have them contained within the virtual network's full IP range. That's really the only requirement. You can pick a size that matches your requirements. The default it tends to go is a /24, which gives you, in this case, about 250 IPs. You can choose to make that larger or smaller to meet your needs. It is important to note capital G, capital S, gateway subnet. Some Azure services, like a gateway to an on-premises location, do require some dedicated subnet space. So even though it's in your private area, you're going to need to give us a space for us to work in, to provision those resources to manage on your behalf. A gateway is a classic example. Azure Bastion is another one. There's many different services that use this modality to be able to work within your private space without necessarily having to go out and kind of configure stuff themselves. This segmentation allows you to control what traffic flows where. And by default, subnets can communicate with one another, but we can always add and augment our virtual network down the line to change how things function. So we have the virtual network at the top level, subnets slicing it into different pieces depending on what you're using it for, and the last piece of the puzzle right down at the bottom is the private IP. This private IP allows us to, well, land something with an address. Say this VM lives here. Private IPs come in 2 flavors in Azure, either dynamic or statically assigned. Take your pick. Dynamic assignment is the default because it allows us to just create things quickly. And then you can always choose to statically assign them later. But it is important to note, this is not something you'll be rolling with your own server to do this allocation. In an on-premises environment, you may be used to rolling your own DHCP server. In Azure, that's not required and in fact is not allowed. You need to use the Azure platform itself, the portal, the CLI, PowerShell, whatever you choose to use to interface and dynamically or statically allocate those IPs. We actually use a special IP address, 168.63.129.16. This IP will come up a lot, and this is the special IP that internal services use to reach out and find out what their IP address needs to be. So, set it in the Azure environment, and then it will be able to go through and automatically tell the machine what IP it needs to have there. I've got a couple of examples of different types of things that make use of private IPs, but no, this isn't exhaustive. Virtual machines are certainly one of the more common things, but load balancers of various types, containers, a whole range of different things can make use of them in your environment. All right, we now have our structure. Virtual networks have subnets, subnets have IPs, and we are now able to control what traffic goes where by just allocating things in the right spot. Now, the last thing I'm going to talk about, but frankly the most important thing, is where is your virtual network? It's all logical. So what region are you going to have your virtual network in? Regions in Azure are, as they kind of sound, they are regions of the world. We'll have different data centers in different locations to ensure that you can have a network resource close to your customers, whether those be internal or external. Now, picking a region is pretty much the first thing you have to define when you build out a virtual network. Name and a region and a subscription to land it in, somewhere for us to bill and do various constructs around permission structures, that's going to be important. When you pick your region, go simply based on where your customers are. There may also be compliance regions that you'll pick one location over another. Every business is slightly different. But know that virtual networks actually have mechanisms for spanning across subscriptions. So you're not tethered in quite the same way as other Azure resources. The networking stack's really interesting, pretty unique for that. All right, let's dive into the portal now. What we're going to do is create a virtual network. I'm just going to run you through some of the basics of it. We won't go through the whole thing, but I want to show you some of those critical steps that you need to pick early on and what you can change down the line. Let's head into it now. All right, so in front of me is the Azure portal, and we've got a couple of virtual networks already spun up, mostly in the East US here. What I'm going to do is create a new virtual network for our West US region. I'll be using that a little bit later. I'm sure the business will be interested in putting that one there. What we'll do is hit create and jump through some of the initial hoops of getting ourselves set up. Now, if you remember, one of the first things I said to pick was a place to store. We're going to go our core networking resource group here. And then we need to pick a name and a region. I'm going to go with my shared West US hub, following my naming convention. And we're going to pick West US region here. We'll go West US 2 for this one. Name it accordingly. From here, we can jump in to our IP addresses tab at the top here and start picking out our address space. Now, I happen to know that one of the other virtual networks is actually already using this 10.0.0.0/16 space. So I would like to actually change this CIDR block. I can do this pretty easily, simply by making a change here. We can update that so we see the full range of IPs that are being utilized by this virtual network. And we can easily go through and make edits to any subnets that are being created. 10.3, beautiful, update those accordingly, and start at 10.3 there. It'll always give us any warnings if something doesn't match quite right. It's one of the reasons why I like doing this in the portal. If you prefer doing this via template or via a PowerShell or CLI, you can go right ahead. Now, at this stage, we can also go through and add a few extra subnets if we need to. I'm only using a small portion of the full set of 65,000-ish IPs that I've got on hand here. So I'm going to go through and actually preempt something that I know the business is going to want to do later. We're going to create a service here. Virtual Network Gateway, named Gateway Subnet, and then we can pick how big we wish that to be. So we'll go to our IP address range here, 10.3.0.0, choose our starting address, and the size has been auto-populated for us to match the service we're looking to deploy. So there's a few nice quality of life things put in place. And at this stage, we've got most of what we need. Some of the security things are things that can either be added later or on demand. Tagging to ensure that your resources are, tagged correctly and you know what belongs to what. But when you're ready, you can hit review and create and then simply hit that create button there. All right, deployment is going. We'll be back in just a moment. And we're back. We can see a few key things about the virtual network I've just created. The location of it, the address space. We can see that we're using the default Azure DNS addresses and that everything is really ready to go. In total, it only took about 15 seconds to be able to deploy this virtual network. And keep that in mind. The virtual networking stack is purely logical. We want you to be able to create it when you need it and exactly as you need it. If at any point you need to add additional subnets, you can easily do that in the portal menu on the left-hand side here. It's a pop-out for me. Head down to your subnet space and just add the ones as required. You don't have to get it right at the beginning. And in fact, we can actually go through and make some resizings here. Let's say I'm finding that /24, this 250 IPs, is a little large for my default subnet there. I can easily go through and I can maybe change that to a /26, something a little bit smaller. It even gives me an estimation of the number of IPs that I can expect to see. In this particular case, 59 plus the 5 reserved IPs that I have in place. When I'm ready, I can hit save, and that will make the alteration for me on the fly. Simple, easy, logical networking. Up ahead, we're going to be looking at public IP addresses. This is the stuff we need when we're communicating both out to the internet and in from the internet. And in fact, public IPs, primarily, it's that in traction that we need them for, where we have a service that we wish for others to consume across the broader internet infrastructure. We're going to be looking at a few different areas of public IP configuration. A little bit on picking the right SKU, or stock keeper's unit. Think of it like a t-shirt size, as well as just the process of actually creating a public IP. And I know there's many people over the years that have asked it. I'm also going to talk a little bit about bring your own IP, how you can take an IP range that you already own and actually utilize that in Azure. Let's jump into it. Now, what you see here is a non-exhaustive list of all of the different services that consume public IPs. Things that we want people from the broader internet to be able to come in and make use of. For example, a virtual machine. I have a service hosted on there that I need people to be able to access. That sounds pretty logical to me. Maybe I'm running a web server or running an application for someone. I could also have that behind a load balancer or anything along those lines where we're abstracting that out. Again, it makes sense. Ones that you might not think about are things like VPN gateways or Azure Firewall. Things that we are using as an ingestion mechanism. So when someone is coming through into our environment, we're able to evaluate the traffic. Or more to the point, we've got a reference point for where that sits in the environment. Again, this is non-exhaustive, but it represents the most common things that we see, the most common resource types that you will encounter that utilize this public IP type. Now, in terms of your public IPs, 2 major SKUs that you can pick of, and one that I'm going to recommend. The standard SKU is what you will use 100% of the time. The basic SKU is on the depreciation pathway, so it is something that we really only utilize in sandpit style environments, where we're getting a grip of something and want to test stuff out. It doesn't have the same security defaults or any of the things that we would come to expect for a modern enterprise environment. So if you are building out an application that requires a static allocation, that point in the internet that represents you, and you want to ensure that you are secure by default, pick that standard SKU. There's also a number of interesting features around availability that you get under the standard SKU. Mostly that you can actually deploy a public IP in what we call a zone redundant configuration. In regions that support availability zones, you can ensure that there is actually a triplicate deployment of your public IP across multiple different physical data centers with separate power, water, internet. If we have this disparate setup in this way, you're more protected against an individual failure of a power company or a water supply or an air conditioner. These things can really help with your resiliency levels and ensure that things stay up for you when you need it the most. Now, there are 2 different ways that we can provision public IPs, either on their own, one at a time, or as a block. You can actually choose to provision maybe 8, 16 IPs at once. That option to be able to provision multiple IPs is useful if we're creating something like a NAT gateway that's going to make use of lots of IPs, or maybe a scale set with virtual machines with lots of different endpoints. That second one though, the scaling component, that ability for us to pick multiple IPs, is how we have done the bring your own IP service. So let's say right now you have a set of IPs that you own, things that represent you to the internet, and your customers are already familiar with that. Rather than creating a public IP, which is a slice of the Azure public IP range, and allocating that to yourself, instead, you can actually go through a process of route authorization, working with registries to prove, yeah, I own these. Once you've gone through that process, you're able to utilize that custom IP prefix in Azure for services just like you would any other public IP. It's an extremely useful thing for established enterprises that already have a very strong and long relationship with customers that expect them to come in on certain ranges. There is a process that you do need to go through. It starts with an initial validation, a provisioning, and then a final commissioning process. I recommend going to the Microsoft Docs to be able to read more details there, available at learn.microsoft.com. All right. Let's jump in and take a look at the portal. It's an easy way for us to be able to create public IPs, and I just want to show you a little bit of how it's actually done for both an individual IP and for a prefix where you require multiples. Here we are in the portal. Let's go take a look at how we actually create a public IP. I've got a few here already, but the main thing I want to show you is how you actually get allocated one. I'll hit the create process here. And this will begin the process of getting stuff stood up. Like every other resource in Azure, you will require a resource group. We will pick our core networking and a region. Public IPs differ per region in Azure, so make sure you pick the right one. And in the configuration details here, there are a few interesting things that you can set up. If you are an IPv6 customer and you are making use of that, I would recommend looking at those details there. I'm going to choose IPv4 for my preferences here. So let's just create our quick public IP. And this is where we get some of our different options around the different SKUs that we can use. Again, I recommend picking the standard SKU there, and also our availability zones. Zone redundant means I have that triplicate set up, but we can deploy to single zones in a region if you would prefer. Since I have picked an availability zone supported region, we're getting what we expect. The last thing down here, regional or global. For the large majority of things that you will provision, different resource types that make use of public IPs, you will leave this on the regional tab. But there are some scenarios involving load balancers that work across region where you may wish to pick a global instead. For more information, head to Microsoft Learn to see more details there. At this stage, we're actually done. If all you need is a public IP from the general addressing space that Azure has, you can hit review and create, and we'll provision that IP for you. Simply pick one from our general range of IPs to allocate your way. What we can also do though is create that prefix as I mentioned. If I go across to my IP prefixes, I can hit create, and we'll see something very similar. Still need to pick a resource group, still need to pick a name, and need to pick a region. Nice things. Public IP prefix 001. But there's a few more details down the bottom here. We must pick standard for the SKU. We can pick IPv4 or 6, and the prefix ownership. Microsoft owned simply means we're going to give you multiple IPs, 2, 4, 8, or 16. If you're bringing your own, hit custom IP prefix, and the details here will change as well. What is the particular prefix you're using? How large is it going to be? All those details can be put in place. If you don't have some IPs that you wish to bring from another registry, don't stress. Simply hit create on the ones you need. Routing preferences, all of those details are still the same as choosing and creating a normal public IP. I can hit review and create, and then we're done. The allocation process takes about 15-20 seconds. Like most Azure resources in the networking stack, this is a very quick deployment. So you can create them as required. And here we go. Here is my public IP prefix, and you can see that an IP has been selected on behalf for me, this IP range here, and we've got a /29, which represents the number of IPs that I've selected. We can even see how many are currently allocated to different resources in Azure. So if you need to have a contiguous range of IPs, this is an easy way to get it done. we're going to be looking at name resolution for virtual networks, specifically how public DNS functions and how Azure works by default in our environment. Let's jump into it. There are a few different things that I will need to cover to make sure you've got your bases covered around domain name resolution on the whole. First, we're going to look at public DNS and how it actually functions in Azure by default. It's important to know what it looks like when a request comes through for a friendly name and how that gets translated across to an IP address. What I'll then be showing you is a number of different ways to leverage this yourself. By creating a DNS zone, you'll be able to make your own records and actually use that to your own advantage. Ensure that people coming in don't need to know some arbitrary IP address to be able to get into your environment and find the site they're looking for. They can just use something a little bit friendlier and a little bit more human readable. Let's begin with that public DNS. Let's just talk about how this functions in Azure at a high level. Public DNS in Azure starts with a query, something for the site you're looking for. In this case, contoso.xyz. Doesn't really matter what it is. The process remains roughly the same. The request reaches Azure DNS, and then it gets passed to one of 4 name servers. These name servers will then round robin return the details back to the customer or back to the person requesting that information with the IP address that they're looking for. This resolution format is what we will see for a host record or an A name record. We're looking for a host and how to translate that across to an IP address. The other one you might find is CNAME records, which is where we're translating from one host name to another host name. There are other types that Azure DNS supports, but we'll get to that when we get to that. Right now, focus on this as the fundamental thing. You put in a request as someone who wishes to access a resource using a friendly name, and it gets passed back to you with the correct information to ensure you get to the right location. So how do we leverage this ourselves? It's all through the process of creating a zone. DNS zones are the thing that let us put in details about what this redirection actually does. What is the website name that we are looking to actually redress? What is that host name that we're looking to respond to? Azure Admin Inc. is a particular example that I have here. Doesn't really matter, again, what it is. The point is there is a reference for us to make use of. When we receive a request for that particular web address, we are able to translate everything correctly. Now, each zone can be used in a number of different ways. And if you are testing things in different environments, you can actually have multiple DNS zones, one representing production, dev test, pre-production, and then point your resources at each of those zones manually. The way that we do this is through a clever use of the name servers. When we are looking to utilize this DNS name that we have created, the zone, we are provided with 4 name servers. Now, these are not physical servers running somewhere. It's all virtualized and it's all load balanced, which is the point. There are 4 name servers, .com, .net, .org, and .info, and you will use all 4. Whether it be with your registrar or if you're doing this in a dev test pre-prod zone by just pointing people at the name servers manually. Once you create your DNS zone, you can then go through the process of saying, hey registrar, I do own this. And there is a clear kind of step-by-step guidance available in learn.microsoft.com on how to achieve that. Now, if you are looking to use child zones, we do the name server record at the parent domain first, and then we can kind of work our way through there to build things up as we need to. So the zone represents the URL, the site name, the domain that we're looking to utilize. Record sets are where we need to redirect that traffic. When I receive a request for www.contoso.com, what does that mean? Here in this example, we can see helloworld.azureadmininc.org is of the type A. Change that dropdown and you get access to all of the common DNS record types that you would expect in any normal enterprise environment. A name, C name, MX records for your mail server, TXT records, whatever it is that you need to put in place, you can do that. When you are actually going through and setting up your record set, there's only a few things you really need to consider. 1, no duplicates. Each record set cannot contain 2 identical records within it. Makes sense. You can put multiple IP addresses in this listing here, and by simply populating the first one, things will open up. And that goes for the dropdown for the type as well. By changing that dropdown, you'll be presented with the exact information needed to get this up and running. Of course, this is fully addressable via PowerShell or the CLI. Take your preference, whatever works best for you there. We're going to be looking at the private name resolution within Azure Virtual Networks. Rather than things coming from the public internet where we want to resolve for a public website, how do we deal with things when it's internal? The site we're looking to access or the resource we're looking to address is not something that needs to be addressable via the web. We get a lot more flexibility, so let's see how it's done. I want to first show you how private domains work within Azure, but I am also going to cover and touch on a little bit of how you can roll this yourself if you choose to use your own DNS servers. Let's dive through bit by bit. When we are looking to set up DNS in our private environment, this domain name resolution has a bit of a different purpose to it. We can see here a private.contoso.com, something that is internal, used mostly for maybe hostname management or an internal website that's only accessed by users on the corporate network. These DNS resolutions like this are still done via a zone. We will create a private zone, and this will contain any records that we wish to put in place. Now, this is just what we would expect out of any DNS service, the ability to create A-name records, C-name records, all of the usual things. What we get specifically with private zones in Azure is the ability to have auto-registration of new resources as they are created. So you don't need to go through and push changes every time you create, say, a virtual machine. In fact, let's take that example specifically. I have a virtual network and I wish to have any new virtual machines pushed into it, updated with a new DNS record that represents them. This is that example. The left-hand side, we have a virtual network that is marked for registration. To do this, I've created my private zone in the portal. I go through and I point the virtual network at it. By doing this, any new resources that get created, in this case virtual machines is what we're looking at, that consumes a private IP will have a new record associated in Azure DNS for that private zone. By the same token, if something gets deleted, the record gets removed automatically. You don't have to manage each individual record for each individual resource. Where this is super useful though, is not necessarily just on the registration side. Resolution. We can actually mark virtual networks for resolution of these IPs as well. This association means that if someone is trying to reach, in this example, virtual machine 1, VM1 there, they can go to vm1.contoso.lab from any associated virtual network and they'll be able to find it quick smart. Now there is one big thing to remember around this type of registration and resolution. It works in Azure and is designed for Azure. Now there's a big reason that this happens. This IP address, 168.63.129.16, is a special IP that we use to be able to pass metadata down through to resources in an Azure virtual network. One of the things that we gather from here, alongside DHCP requests, the little things like ready signals, is DNS. The ability for an Azure virtual machine to be able to reach out to the Azure Resource Manager and find out what other things are available via DNS is entirely controlled through this IP. We'll then make use of the .2 and .3 in a virtual network subnet, those allocated IPs that we reserve, to be able to finish that request up. Extremely important to know what this IP is for and how we use it. So, this is designed to work within an Azure environment. What if you're in a hybrid state? Well, there's a couple of ways that we could address this. but I want to first look at the way that you can effectively just do it by rolling DNS yourself. You're under no obligation to use the Azure DNS infrastructure. If you have DNS servers already, we can actually use a combination of DNS servers and forwarders to be able to handle requests with any private zone. Let's look at an example for this one. In the bottom here, I have my on-premises environment. Now, this on-prem environment that you're seeing here has some DNS zones already, some servers that are running that I've been maintaining. What I want to do is have any queries that are for the virtual networks in Azure be forwarded along. So first of all, we can tell each of these virtual networks, hey, you've got DNS servers on-prem. Use those if you've got a request. But if you don't see the one you're looking for, ping off to this forwarder that's running in the Azure Virtual Network. Remember, the ability to do this resolution is for resources in Azure. It's built around Azure. So all we need is a DNS server or a forwarder in Azure to handle the request. Let's say this virtual machine here wants to push a DNS query to find out about one of the other virtual machines in an environment. No problem. It'll ping out to the DNS server that you are running there. It'll do its query and it'll roll it back. Once it's got that request, you're done. But if the request is for an on-premises resource instead, well, the workflow looks a little bit different. It'll make the request to DNS server here, and then it'll simply forward the request on via your hybrid connection. There's lots of different ways we can slice this, and I recommend looking at the learn.microsoft.com documentation around how you can use different name resolution strategies depending on how you wish to set up your enterprise environment. Coming up, we're going to be looking at cross-virtual network connectivity through the use of peering. Now, peering is by far the simplest way for us to be able to connect any two virtual networks in Azure together. It's not something that happens immediately, and it requires a little bit of work and a little bit of preparation, but by far it is the simplest to manage. We'll look at virtual network peering at a high level and then look at a few specifics along the way. Things like gateway transit and service chaining are important for you to know as terms to make sure that everything's working correctly. So we'll start with an explanation of peering and work our way through some of the other bits and pieces and extras that you can add along the way. Now here in Azure, peering comes in a few different flavors. Ultimately, it's really pretty straightforward. If you have two virtual networks that are in the same region, we will use a local regional peer for this. Regional peering is common where you have to create a hub-spoke network topology, or maybe you want to interlink two workloads that are in separate virtual networks through to one another. Alternatively, instead of a local peer like this, we can actually set things up between regions. Any two virtual networks can be interlinked across regional boundaries, and we'll use the Azure Backbone network to be able to traverse privately from A to B. Extremely useful if you are interconnecting multiple sites or if you have a workload that is running in a different Azure region. Regardless of what you are using, the process of setting things up is nigh identical. Heading into the portal or using the CLI or a template, you can simply configure the directions on both sides of the fence. What communication would you like to go from A to A2 or A2 here to B1? Is it unidirectional, bidirectional? That's in your hands. There are a few little caveats along the way that are important, and this is where planning makes a big, big difference. The first is that any two virtual networks that are peered cannot overlap. Do not have virtual networks overlap and attempt to peer. We simply won't let you. This isn't so we know where traffic needs to flow correctly, what that next hop looks like. Honestly, if you've got that in place, you're kind of in a good stead. Peering can be used within a single subscription, across subscriptions, and even across tenants to interlink different network locations together. So now that we've got the fundamentals of VNet peering, let's dive just a little bit into it. I want to talk about two common scenarios that we would make use of here that are going to involve some other pieces of the network configuration down the line. The first you'll see on the left-hand side of the screen. What we have is a virtual network connected into a central location with shared resources, the hub. This hub contains a network virtual appliance. Maybe it's a firewall or a security device. But what we need is traffic that is leaving VNet A to first go through this device. The easiest way to ensure that the traffic flows in this direction is via a peer. We are able to set a custom route, and this can actually be done on the subnet level, to ensure that traffic is forced to go in one direction. And we will traverse that peer to make sure that the traffic hits that network virtual appliance on the way out. It's extremely easy to set something like this up, and as long as there is no overlap, you're in a good spot to be able to get it running. The other kind of common scenario that I tend to see with customers is the one on the right-hand side here. You've set up a connection through to your on-premises network using a gateway. And we want to ensure that we're keeping costs low and also centralizing this traffic because it is quite an open security risk, right? That ability to connect back to on-premises, no matter the layers of security you apply, there's always a risk there. So we want to control how traffic flows to it and who can make use of it. We don't want to have a million gateways all pointing to different directions and lose the plot of where things are. So by centralizing your gateway in a hub like this, we can actually tick a box in the peer to allow gateway transit, which says anything in VNet B that is trying to reach back to your on-premises location, use the gateway located in the hub. Network virtual appliances, gateways, firewalls. These are things that we want to share amongst our network resources. So putting them in this central spot and using peering to ensure the traffic traverses privately that way is an easy solution and a quick win. One of the important things that we can leverage with this idea of peering through a hub is service chaining. This is where we can utilize a central location that is able to control routes, next hops, and where traffic flows, and use the resources there to ensure that traffic is flowing securely and in a controlled manner between different segments of our network. Let's talk very wishy-washy. Let's talk real examples here. I have a virtual machine in VNet 3 in the bottom right-hand corner, and it wishes to communicate with a virtual machine up in VNet 2. I want this traffic to be private, and I want it to carry entirely across my private virtual network stack. Peering is your solution. Create a peer from each of these virtual networks through to the hub. By doing this, we are able to facilitate a pathway. Next, we just need to tell things how to get there. And the easiest way to do this is via a network virtual appliance. There are many third-party appliances that are available in Azure, and we do also have some first-party offerings that can assist with this. But the point is, the request will go from Virtual Network 3 through to the hub, and something in your hub will handle that request and on-forward it to Virtual Network 2. If you're looking to do centralized security monitoring or looking to control where your traffic flows in a centralized manner, this is the easiest way to achieve it. So look to peering and the service chaining model to build your environment out there. What we'll do now is jump into the portal and have a little bit of a look at getting a peer set up. There's a couple of things that we can do which allows me to just show off exactly how it works and also how things all flow together when you're in the portal. Here we are in the portal, and you can see I've got a few virtual networks already up and running. Now what I want to do is actually do a global peer between two hubs. We're going to link East US and our West US 2 hub here. By clicking into East US, we can open up the menu on the left-hand side, scroll on down into the settings, and you'll see that peerings appears. By going into my peerings, I can see I've actually already enabled one out to one of the spokes. So you can have multiple peers going through one virtual network. Easy way to set up that hub and what we call a spoke model. Hub being the central shared location, spokes being the virtual networks where resources are located. What we're going to be creating is a hub-to-hub connection. Nothing changes in terms of how this is done. It's just about what the architectural model looks like. By hitting Add here, I'm presented with a few different options. Now we know we are going from one hub to another, so we are going hub East US to hub West US 2. These names can be anything you like, but I recommend keeping them so they're easy to read. Now you're presented with a few different options here. The first, do we allow the VNet shared East US hub to access the peered virtual network? i.e., do we want the hub connection to be in this direction? We can also take a look at things like requests for forwarded traffic. Do we wish to allow traffic to be forwarded through to the hub and then passed along? There's a few other connections here around gateways and how we're going to use these. But for now, I'm just going to be ticking these top two. I don't yet have my gateway set up, and these are the two core things that I want by default. Now, we just need to create this in the opposite direction. So, West US 2, hub West US 2 to hub East US. So creating this in the opposite direction. We'll need to pick our virtual network, and we'll pick our West US hub. And note we're immediately presented with all the same options here. Creating a peer is creating a bidirectional set of view resources. So one for one direction and one for the other. Quite literally, look at the top right-hand corner of my screen. When I hit Add here, two deployments kick off. One for the direction from East US to West US, and the other from West US to East US. These are separate resources that we'll be managing separately, even if they're interlinked together. And once I hit refresh here, we can see that's already in a connected state, and you can easily go through, click into the hub here, and modify any details that you need to over time. Note it's changed a couple of defaults for me based on what's available. Full synchronization is what we're looking for, and if you have that instead, you're actually done. You can customize things down the line and make a few more changes if you want to, but right now, those virtual networks are linked and resources can easily cross-communicate across that private pathway you've set up. From here, we can easily click back to our virtual networks and we can go check the West US hub. West US 2, if we go into the menu, scroll on down, into our peerings, you'll see that connection has happened in the opposite direction there. We can literally see where it's peered across to and all the details you need about that getting set up. If at any point you need to make a modification, you can do that here. And if you do change any details about your subnets, you can resynchronize by hitting that sync button. We're going to be looking at Azure Virtual Network Traffic Routing. And I want to be specific here. What we're going to be looking at is the default state. It's important to know how your virtual network is going to behave, and before we go any further and start talking about how to modify it. When you set up a virtual network, what can you expect from day one? Virtual network traffic routing is all controlled via a route table. And whether you have created a custom route table or are using your own, just the default setup in Azure, one is effectively populated in the backend as a kind of fallback. There are three different types of routes that we support in Azure. Custom routes, which are ones that you can add on and always take precedence. And aside from that, we also have default routes and optional default routes. Between these, you can expect to see, say, traffic in between a virtual network. That's actually what we're seeing here. This is what I would expect to see within my default route. An example of an optional default route would be something like if we were to create a peer between two virtual networks. It auto-populate the route between those networks into your back-end route table. Where this is really useful is that you can actually set custom routes on top of a subnet, add your own table to it, but still have the default posture as a fallback if you wish. It's your call on how you'd like to use this, but it is important to know what the traffic looks like by default. So if we take an example of a virtual network with two subnets in it, traffic will be able to communicate within a subnet or across subnets and within that virtual network itself. But unless you make some sort of secondary connection, traffic stays within the VNet unless it is looking to hop out to the internet, as we have in our example here. This default hop to the internet is something that is looking to be changed in the future, so keep an eye out on that one. Up ahead, we're going to be looking at custom virtual network routing. There are many different things that happen by default in Azure, and there's many good reasons that we would want to change this behavior. So, what do we do if we want to change where things go in our network? Well, one of the easiest ways to affect this is via user-defined routes, which is something that we can configure in a route table. I'm going to be looking at a few other things as well, such as diagnostics and how route service can help you when you're using third-party appliances. But let's start at the top. How do you actually set up your user-defined routes? So, in front of us here, we have a fairly typical Azure environment. We've got an external on-premises location, one that's up in the cloud, it's got a firewall, it's got a few other things running together. But there's a few things that I would like to affect. Now, by default, traffic that is in subnet A on the left-hand side there won't necessarily pass through a firewall on the way out. That's something that we can configure via a user-defined route. What we need to set up is the next hop. So I can set a next hop that says if traffic is headed towards the internet, it must pass through the firewall first. We configure a route table with this piece of information, and then we apply that to the subnet here. By the same token, that route table could also have something that says, if I'm traversing between subnet A and subnet B, I require security analysis via a network virtual appliance. Again, route tables with that next hop configuration telling us where we need to go to find the thing we're looking for really can change how traffic flows in an environment. Because by default, things that are in a virtual network, even in different subnets, can communicate with one another freely. This way, we've actually managed to affect it with two simple changes that can be applied to an environment. We can apply similar route tables to subnet B over here, and we could even have routes that say, follow the gateway back to on-premises if I don't know where the traffic goes. There's a lot of different configurations we can put in place depending on whether you are focused on a compliance framework, whether you're focused on security, or you're just focused on efficiency. Next hops really do make the difference as to whether your network runs nicely or if it just runs. So let's presume we've got a route table set up, something already in place, and we want to apply that to a subnet. I want to do one specific thing here. I wish to create a route that says traffic that is headed for a particular IP range must pass through a virtual appliance. Let's do it. I create a route called toPrivateSubnet, and if my traffic is destined for this IP address range here, 10.0.10/24, then my next hop, where I go to send that traffic, is the virtual appliance. Now this could be your network virtual appliance, a firewall, any number of things. Once I've configured that rule, all I have to do is on the subnet configuration, associate the route table. By doing that, I have started enforcing these routes. So a simple change like this can make a huge difference to how the network traffic flows. That example of sending traffic back to on-premises, that's another great reason why we might want to use a route table to affect routes. It's actually got a name, forced tunneling. We take traffic that is not destined to go anywhere, and we can actually set a default route. This one here, 0000/0. If you ever see this CIDR block, this effectively means all IPs. So if I work my way down the list of things in my route table and I don't have a match, the last entry will be this one here. and this can be considered our new default. This is useful if you want to force all traffic to go back to an on-premises security device for analysis, or you want to ensure that all traffic you don't recognize is passing through a firewall. There's a whole bunch of different ways that we can use this, but that idea of having this default route at the end really can shape how you have your posture in your environment. Now, the last thing I want to look at is how we can actually propagate these routes out, because really they're kind of locked to the subnet that they're in. If we wish to have them move out and kind of propagate and populate elsewhere, we need something else to be able to read those routes and pass them along. The thing you're looking for is Azure Route Server. Now, Azure Route Server is designed to work with network virtual appliances that support BGP, or the Border Gateway Protocol. BGP allows us to represent a bulk lot of IPs with a special number that carries through, and we can pass that along to other devices. It's a way of different network devices of different brands communicating what IP ranges are available with one another. Where this is really useful is that if you have an Azure environment with a number of populated route tables, we can actually use Azure Route Server to pick those routes up and pass them along to your network appliances. This is especially useful because it means you don't have to manually update things in those appliances any longer. It's automatically just picking things up, and then it will withdraw those routes when Azure says the route has been removed. If you are using third-party NVAs, make sure you look at Route Server as an easy way to just reduce your overhead and generally have a better time maintaining the environment. In the video up ahead, we're going to be talking about Azure Virtual NAT. Now, Azure Virtual NAT, it allows us to do network address translation. What is network address translation? We'll touch on it in a tick. But the main thing to know about the service is that it is about the idea of controlling outbound traffic. When we are looking at NAT, we're going to be looking at how to actually deploy the service itself, how to get things set up, and I'm going to show you just an example of how an architecture looks when you are coexisting with some inbound connectivity. Let's jump into it. Now, that idea of coexisting with inbound, that's important. Azure Virtual Network NAT is designed as a way of controlling outbound traffic. So, when traffic leaves a subnet and it is intended for, say, the public internet, where does it usually go? Typically, it'll just head through the default gateway in the subnet and it'll kind of just work its way out to the internet. Using something like Virtual Network NAT, we can attach the service to a subnet and force traffic to pass that way if it is going to go out to the internet. Now, where this is useful, whether you select a single public IP or a cluster of IPs, you're able to have multiple different servers, services, virtual machines, whatever it is, in that subnet use the same public IP. What's especially useful is that traffic that heads out through Virtual Network NAT will make its way back in. So we are avoiding asymmetrical routing. This allows us to control exactly what IPs things in our environment are going to make use of when they're communicating with the outside world. So let's dive a little bit deeper on this. Let's say I've got some services that are actually communicating out with the world already. And I don't mean in the sense of they're going and fetching an update or something like that. I mean I'm running a load balancer and I have virtual machines people reaching my virtual machines in the back end there. I can work through my public IP and people can still reach that load balancer. But by the same token, if each of these virtual machines individually need to reach out to the internet, actually updating is a great example, need to reach out to fetch an update, then they can traverse either via a public IP that is assigned to them one-on-one, or use Virtual Network NAT where multiple virtual machines can utilize that same pool of IPs we put up here. No matter which way you do this, you will get the correct network address because these are stateful. They understand how things are being translated and what the flow direction is. So it's extremely easy to set up but it gives us some, at the very least, obfuscation over what exact machine is communicating out with the web. But at the very least, it allows our partners to know this one IP represents all of my virtual machines for this particular project. We can kind of collate things together and allow us a lot more control over how things actually flow. So how do we get this stood up? Let's jump across to the portal and create one quickly. It's a relatively straightforward process, and there's only a few things you'll need to consider. So here we've got the NAT Gateways page. Nothing really here right now. I don't have any provisioned. So let's go and create one. I'll hit the Create button, and there'll be a few things you'll need to consider, same as you do really every other resource in Azure. The first is where it's going to be. It's a networking resource. And this is a NAT Gateway 001. And I'm going to put this one in East US because that is where I have my resourcing that I need to allocate this to. Next, outbound IPs. So what public IP am I going to make use of? We can either create fresh ones here, or we can actually select pre-existing ones. Note this can be individual public IPs, or it can be a public IP prefix, which are contiguous IPs mapped one-to-one. Once we've got our set of front ends, we need to say what in the back end can actually use it. Configuring your subnet here is going to be filtered by region. I'm going to select my hub, and then I just need to select which particular things are going to make use of it. I'm going to select these two shared subnets here. And that's it. Once you have set this up, the NAT gateway naturally integrates into your virtual network structure, and there's nothing really else that you need to change. All you really have is a set of servers that make easy use of these IPs, and so you've got a static set of continuous IPs that are guaranteed to be where your traffic is headed out from your environment there. Simply hit the Create button and things will be ready to go in not too long at all.